So now you have the mean, the median, and the mode. So you have an idea of what the central value of a data set is. But that doesn't quite tell us everything about the data. It doesn't tell us how spread out the observations are. So are they tightly clustered around the mean and the median, or are they really spread out? How spread out the data is can be really important too. So in this clip, we're going to talk about standard deviation and to see how standard deviation is calculated. So standard deviation is a statistical measure of data dispersion that shows how much data points in a set are spread out around the mean. So low standard deviation means that data is clustered tightly around the mean, while a high standard deviation means that there's a lot of variation and the data is spread out over a much wider range. It's most commonly represented in mathematical texts and in equations by the lower Greek letter sigma. So let's go back to our spreadsheet. So we have the hours worked from employees again. So it looks like the hours worked are kind of spread out. Up here we have some workers with only, their hours per week are only in the 20s. And down here we have some workers up in the 50s and even over 60. So I'm going to calculate the standard deviation. I'm going to go through each step here and then just show you the function afterwards. Um, so the first thing we need to do is to get the mean or the average, which you already did last time, the 41.39. So what we're going to do is take that value and subtract it from each of these observations. So this is C45. So I'll go up here and write C45. Now the reason we put in the cash signs is basically to hold that in place. So as we copy this down, it's going to have that exact cell in. Oops. Sorry about that. I got a little too excited. So we'll do equals the number minus C45, so minus the average. Here we go. We can calculate that for the first one, and we can carry it all the way down through all the data points. Now, what we want to do next is to square that difference. So we're just going to take that equals. We're going to use the caret sign or up and then 2 to square it. So that'll be each number multiplied by itself. Now what I'm going to do is that now that I have the square differences, I'm going to sum those square differences. So sum the column of data right here in E. So equals sum. So that gives us this number, 3,026 and some decimal points. After that, we can divide that number by the number of observations minus 1 because we're working with the sample here. So I said there were 43 observations, so we'll want to divide this number by 42, so 43 minus 1. And this gives us our variance. To calculate the standard deviation, it's just the square root of the variance. Because we squared the number in the earlier step, we have to take the square root of it. So square root. So right here we have variance and the standard deviation. Now, if you want to double check this, and when you do it later on your own, you can just use the Excel function. That's much easier. But I wanted to go through so you could see the math. And it's not really complicated to do, but it's much more time consuming than you need to do. Now, here we used, like I said, we used the number of observations minus 1. Now, the reason we did that is because this is a sample. If you were working with a population of data, you would just divide by n, so the number of observations. So it's important to know whether you're using a sample or a population. In this course, I have on one of these slides in here that we're using sample data. We'll be using sample data in this course. You can assume that unless otherwise we say that it's the population. But if you're doing, say, your project for the overall course, you may be working with a population of data. If that's the case, then you'll want to know that for how you calculate the standard deviation.